Welcome to Spring LIB.
Okay, we've been told that enthalpy of vaporization, which is 29200 joules per mole, and we've been told that at 275 Kelvin, this particular compound has a vapor pressure of 117 millimeters mercury, and we're asked what the vapor pressure would be at 307 Kelvin. Okay, what we need to answer this question is the Clausius-Clapeyron equation. So I will draw that out. Clausius-Clapeyron. I think I've never been quite sure how to pronounce it, but the important part is that the equation is as follows. It is the natural log of pressure 1 over pressure 2. So the ratio between the pressures you're interested in. And then you've got the heat of vaporization, the enthalpy of vaporization over R, times, and then it's 1 over T2 minus 1 over T1. Well, what do we have? What do we need to know? We need to know pressure 2. We know temperature 1, we know temperature 2, and we know the heat of vaporization. So we can plug in this information into the equation and solve for pressure 2. Right? So let's do a little bit of algebra first to isolate P2, and then we'll plug in all the values. How's that sound? Okay, so first we need to get this pressure out of the logarithm. And if we have something in a logarithm and we want to get it out, we can exponentiate. That is, we take both sides of the equation and raise e to those sides of the equation, right? Because the natural log, e raised to the natural log of something is just that something. So we get P1 over P2 out. And then now over here, we've got e, and I'm just going to write this, I'm going to, instead of writing e raised to the, I'm going to use a symbol that represents that fact. It's exp. Oops. Exp, and then you just put it in brackets. Delta H over R, 1 over T2 minus 1 over T1. That's equivalent to e raised to everything in the brackets. Okay, now we want to get P2 isolated, so we can, I'm going to multiply both sides by P2. And I'm going to divide both sides by this exponential. Okay, so when we're done, we'll get P1 over the exponential of delta H over R times 1 over T2 minus 1 over T1. And on the left side, we'll have P2. So now all we need to do is plug in the relevant values right there. So let's go ahead and write that out. P1 is 117 millimeters mercury. Got it. Okay. Then exp of 29200 joules per mole. And down here we're going to have R, which is 8.314. Do they give us any more digits? Sometimes. Yep, they give us a 5. 8.3145 joules per Kelvin per mole. All right, and then here we've got the 1 over T2, which is our 307. That's the one we're being asked about. That's Kelvin. And 1 over 275 Kelvin. And now we just need to compute this. I'm going to pull up my calculator. You won't be able to see it, but that's fine. I'm going to pause the video and calculate it off to the side so you don't have to wait. Okay, and the answer that I got out was P2 equals 442.8892 millimeters mercury. And right, the units should be the same as what we have in the numerator, because everything else will cancel. Joules will cancel with joules. Per mole will cancel with per mole. This is Kelvin in the denominator of the denominator. This is just Kelvin in the denominator and Kelvin in the denominator, so these will cancel as well, leaving us with millimeters mercury. The final thing we could do is round it to give the correct number of sig figs. It would appear that we have 3 sig figs from both the millimeters mercury being 3 sig figs as well as the temperature and heat of vaporization. So the final answer would be 443 millimeters mercury.